Good morning, children. I'm Mary Pothan. Hope you are familiar with motion of objects and its associated physical quantities. Let us learn graphical representation of motion today. Graphs are the best tools for representing any data in an easily understandable form. Graphs are also used to represent motion of an object. We can use distance time graph and velocity time graph to represent motion of objects. Let us see the distance time graph in detail today. Just like any other graph, to plot a distance time graph, we have to take time along the x-axis and distance along the y-axis. And we can calculate the quantity speed of the object from the distance time graph. Let us consider the first case of the distance time graph, that is distance time graph of an object at rest. When do we say an object is at rest? If the object is not changing its position with respect to time, then we call it at rest. The object is at rest. When we are plotting the distance time graph of an object at rest, taking time along the x-axis and distance along the y-axis, we will get a graph which is a straight line that is parallel to the time axis. If the distance time graph is a straight line parallel to the time axis, then we can say that the object is at rest. Next case, distance time graph of an object in uniform motion. What is uniform motion? If an object travels equal distance in equal interval of time, then the object is in uniform motion. Okay, we can plot the distance time graph of an object in uniform motion using the distance time graph, taking time along the x-axis and distance along the y-axis. And this graph will be a straight line which is inclined at a constant angle with the time axis. You can see it is maintaining a constant angle with the time axis. It is a straight line. Okay, and we can calculate the speed of this object between any two time intervals by calculating the slope of the graph. Here you can see a straight line which is inclined at a constant angle with the time axis. We are considering two time limits here, 5 seconds time and 10 seconds time. Within that time, the object is traveling a distance of 20 meters. You can see that. And if we are getting a triangle like this, we call it the slope of the graph. And we can calculate the speed of the object by calculating this slope. That means we are dividing the difference in distance by the difference in time interval. And we will get the slope of the graph, which will be the speed of the object in uniform motion. The third set is the distance time graph for non-uniform motion. When we say non-uniform motion, its speed is varying as time goes on. It may be increasing or it may be decreasing. In both the cases, we can calculate the speed of the object by counting or by calculating the slope between any two time intervals, as in the case of the previous example. Okay, and if the speed is increasing, then the slope will be becoming bigger and bigger. If the speed is decreasing, the slope will become smaller. Okay, so we can identify from the graph whether it is in increasing speed or decreasing speed. Anyway, if this is the shape of the graph or in any other pattern you are getting, that shows it is a non-uniform motion.